Hello and welcome to the Rhapsody May webinar. We're glad you could join us. Today, we're gathered to talk about the importance of semantic interoperability in building healthcare AI. Now, if you've joined one of our webinars before, then you know the routine, but I'll list off a couple housekeeping reminders before we get started. This is a live session and it is being recorded. Anyone who registered for this event will receive a link to it, the recording, within 24 hours. So even if your colleagues couldn't join live, if they registered, they'll get an email with the link as well. If you have any questions, don't hesitate to send them over in the chat. We'll do our best to answer your questions during the session. We should have the time. And if we don't get to it, we'll follow up with you after with the answer. Before we get started, how about we go through a quick round of introductions? The format we will follow today is a conversation between Evgeny, Tammy, and myself. Well, Evgeny, how about you introduce yourself first?
So good morning, everyone. My name is Evgeny Lukipoulis. I lead the Research and Emerging Technology Group at Rhapsody Health. I joined the company last September, so I'm relatively new. My background is in applied mathematics and computer science, but I have been working in healthcare for the last over 25, nearly 30 years. And I'm privileged to lead the part that is letting us put our hands into very, very new and interesting things, some of which we hope we can share with you today. Tammy, over to you.
Thanks, Evgeny. I'm Tammy Jones. I'm the solution consultant for Rhapsody Health, and my focus is on the semantic product. And of course, semantic terminology is what we're talking about today. I've been in healthcare for a number of years, with the last 8 being focused on the terminology management solution. So thanks for the welcome, Shelley, and looking forward to having this discussion.
Great, thank you both. And my name is Shelley Waymeyer. I'm Director of Product and Partner Marketing here at Rhapsody. So today on our agenda, we're going to first start with some observations and themes from our time at HIMSS. We'll talk about one of those themes from HIMSS, which is artificial intelligence and how it's transforming healthcare. We'll also talk about why terminology management needs to be a part of your interoperability strategy and the strategies our customers are deploying to build a solid foundation of high quality data. Evgeny, Tammy, and I all had the pleasure of being at HIMSS to connect with customers, fellow exhibitors, and go check out some sessions. You know, if you weren't there, might be of interest to you to hear that the attendee count was back to nearly the pre-pandemic numbers, with over 33,000 attendees. In the Rhapsody booth, we talked with hundreds of organizations over our 3 days on the show floor. Prevalent themes that our team called out from the 3 days included semantic interoperability, precision medicine, decentralization, blockchain, AI, increasing use of APIs, and interoperable digital identity and patient matching. Of course, from those themes, what we wanted to call out for today was semantic interoperability and AI. And on that topic, I'd like to turn it over to you, Evgeny, to speak through some of the applications that you learned about and some of your overarching understanding of what organizations are focused on.
Yeah, thanks, Shelley. I actually spent most of my time in those sessions that I had the benefit to listen to some very pragmatic examples of how different vendors and mostly healthcare providers leveraged semantic interoperability, but mostly AI in solving their problems. And I'll say, and we could talk about this a little bit later, but AI is so broad and there are so many different components, and also not new. So to me, it was not so much the interesting thing of speculations about what you can do in the future. I think we'll touch on this a little bit later, but more about results, pragmatic results that could be achieved in a fairly short period of time. And I wanted to single out one example that actually stayed in my mind. It was a health system in Florida. I think it was called the Villages Health, and they said, why not trying to see what could be unreported conditions in our database, so that if we eventually would have done better job in reporting them, would have been able to realize additional revenue. And of course, starting from that point on, they were very focused, not just trying to cast a wide net on the things that they wanted to filter, but look at the top 4 conditions that they thought will be bringing them the most revenue. And they found that by combining NLP for looking at the non-structured data in clinical notes, as well as machine learning in classifying structured results, that 15% of the cases have unreported conditions, and that's quite substantial, because they're only looking at, as I said, 4 specific categories, and they saw a peak in degenerative neurological conditions. They then projected this into very pragmatic actions and reported the realization of over 2.5 million of additional revenue. So that was in a fairly short period of time. What they were able to do with the technologies that already existed. What was also notable there is that they took the things that existed on shelf. So they didn't develop too many new things. They just customized what they already have. For example, instead of creating a very complex data warehouse, they took the OMOP data model, and they really did it in such a way so that they could further reuse the data, which is in that OMOP model, for various kinds of other purposes, including quality measures, and practically an effort that was very concentrated to gain some revenue afterwards was able to be taken to a different level, just because there was enough appetite, because of the money that we generated, in order to continue on that track. So that was one example that I wanted to bring out, because it was very focused and demonstrated results in a very short period of time.
Yeah, it's a great use case and a good glimpse of, the theme of the conversation we're going to have today, which is just that, balancing the art of possible with the art of possible with the art of practical. That's quite a pragmatic use case there. And you hit on a couple terms, in describing the Villages Health use case, that might be worth level setting with our audience on what we're referring to. We talk about artificial intelligence as this broad umbrella term for the development of systems designed to analyze data, learn from patterns, and solve problems at scale, mimicking human cognitive process in a way. And then within that, there's different applications of AI or ways to achieve AI that include, the generative AI, large language models, machine learning, and natural language processing. And at HIMSS alone, I remember you had tallied this up for us, Evgeny, that you observed more than 120 companies that were showcasing these various kinds of AI capabilities and ways to use them in the healthcare workflows. Now, Tammy, from your perspective, I know you spent a lot of time on the show floor. What were some of your leading observations from the event and the conversations you had?
Shelley, of course, I was very limited to the booth. It seemed like there were people just flowing in there like a fire hose almost. It was really amazing to see.
You were very popular, Tammy. Every moment I'd be like, oh, I'm gonna grab Tammy. Oh, nope, she's in another conversation. Let's grab Tammy.
And this is really, I think it was really, it was so encouraging to see the growth of the interest in semantic terminology management and what this looks like for interoperability, really. There's always been just a little bit of interest in it, and it had historically been, well, this is nice to have, but I think I can really do it in a spreadsheet somewhere. Well, that doesn't work anymore. And really, people are now, and organizations are recognizing the need for a way to manage this in a way that is an easier lift for them and can be that foundational layer to the AI tools that they're applying on top of this clinical data. So while a lot of these conversations may have started with interoperability and the interoperability suite, they landed at semantic at some point. It was an amazing process to see, and amazing progress really within the healthcare organizations and the healthcare community. So it was a great experience, and I'm so excited for the future of not only semantic interoperability, but semantic interoperability tied together with all of the AI that's out there in the market now.
It totally makes sense to me as why, there's this much buzz right now, across industries and in healthcare included around AI as to why semantic interoperability topic is becoming increasingly popular. You really can't have one without the other, especially as, we've seen in the market, and as we shared in our last webinar, the number of digital tools being used by healthcare delivery organizations is continuing to increase as there's a focus on providing, that optimal patient experience, and making sure then that there's visibility across an organization to the operations, regardless of, where the entity is or what systems are being used by what roles. And ultimately what that all means is there's more data sources, more data types, more terminologies introduced. As we all know, these systems aren't all talking the same language, and different clinical roles are required to document in different standards to meet various requirements worldwide. So that's my long-winded way of saying that I think it makes great sense as to why you're becoming increasingly popular on the HIM show floor, Tammy, even though we've all recognized the opportunity and importance of semantic interoperability with the just increase in the amount of data, number of data sources, and ultimately then the increase in data types. We've got to make sure it's usable and talks.
Absolutely, absolutely.
Now, I flashed up a couple diagrams on the screen as I was talking that demonstrate that, and then this last one I'm showing here shows, that provider organizations, have a desire to be data-driven, but the reality is they aren't all there yet. So again, emphasizing the point I was trying to make.
And Shelley, if I can just add a little bit to that slide that you had before.
Please.
If you go back to that for just a second. There was a recent research done by Accenture that actually noted, and this really ties right into this, and there's different sources that are saying the same thing. So we know it's not an isolated study or a survey, that about 90% of healthcare executives and about 98% of providers are on the same page with generative AI is really going to be a game changer for them. And I think that's really an interesting statistic to know that this is on everybody's mind. It really is. And most of these organizations are planning to or are piloting currently this technology this year. So this is not something that is future state, this is now. And so with those advancements really and those pilots that are going on right now, they also recognize that there's a part of this that, so much of their working hours, like about 40%, could be really supported or augmented by language-based AI. So that's really significant too for a couple of reasons, just because it's supported. It's not only the AI solution. There's human intervention left in here, and human intervention that's required to do that. And I think that's really worth noting in our conversation as we move forward too, that this just because it's AI and this is applied on clinical data doesn't mean that it's excluding human intervention for that.
That's a great point. We had this conversation earlier today to make sure we hit as many time zones as possible. And a point we made in that conversation too was when talking about AI, it's like the rungs of the ladder, and there's different types of models with different objectives and different advancements of it. And at that most basic level, it's analytics, like cross-organizational reporting, right? And automating it in a way that it is intelligent and drives meaningful insights. So it's, the Village's Health sounds like the example Evgeny brought up is doing some quite advanced work in a pragmatic way. But even organizations just trying to achieve basic insights to the organization to drive operational excellence, right? These principles apply.
Well, there are actually two bigger clusters, I would say. One maybe is the analytics and understanding the operational efficiencies, potentials that exist and opportunities. And the other one is directly plugging elements of AI directly into the workflow. And I think if you go to the slide about the digital tools adoption, I would speculate that that's only the tip of the iceberg. There's actually a lot more adoption that is happening behind the scenes, which is not necessarily visible. And that is seen by, for example, very mere facts that the single application, a single EHR, single PACS, whatever kind of powerful tool exists for a specialist or a clinician to do their job is not enough anymore. And it needs to be connected to a lot of other specialized tools. And we already will touch on some of the precision medicine aspects later on. But that necessity to augment the EHRs, to augment the PACS with additional capabilities that sometimes become essential for their workflows has become a much more important thing. So we had the APIs, and the APIs were the mechanisms in order to be able to connect those applications. So I saw it on the slides. We often talk about the data element of it, so the data-driven and the data focus, but don't forget the applications themselves, because you cannot solve a problem by a single application anymore. You need a multitude, and some of those most likely will use AI. My history is very much in the radiology space, and we've seen that in the medical imaging already for a long time. We had computer-aided detection for decades. We had online voice recognition for decades. I mean, we had transcribers who were writing actually the dictations of the radiologists. I mean, that disappeared 20 years ago. So those things are not just improving the workflows, but changing the workflows profoundly by having those tools. And I think we discussed recently also some of the advances made in the ambient intelligence, what Nuance piloted a few years back by recording the patient physician conversation and transcribing directly a report. Imagine that this goes through the Rhapsody semantic and then is get automatically coded afterwards. So these are the things that are not just speculations, they will start happening very soon.
Such potential for impact. Such potential for impact. I'm excited to see how it evolves. Now, there are some exciting announcements at HIMSS about AI being introduced in the clinical workflow in a couple of the big EHR vendors. And for any of that data to be useful to making the predictions that help assist clinical care teams, right? That those models have to be built on clean data, and that's why we're here, and that's why we're talking. If your data is bad, your machine learning tools aren't so useful. And I found this interesting report from the Harvard Business Review that stated data scientists spend up to 80% of their time cleansing data before it's ready to be trained by the AI models for whatever purpose, in this case, predictive medicine purposes. And that's a huge amount of time that could be otherwise spent on honing the model and providing value out of that data versus cleaning it up to be ready for development.
You know, Shelley, this is such an interesting statistic, and even the title of the article that you cited is so telling, right? If your data is bad, your machine learning tools are useless, because at the crux of this, really, the algorithms need to be applied on quality clinical data. They require this standardized data to be able to identify those patterns and make those predictions and generate insights. And if it's not really properly structured or standardized, it can really lead to a lot of errors and bias and inaccurate results. So it's so key to standardize this data and really be speaking the same clinical data language as we're assessing this and compiling the data and cleansing it. To make sure, well, for two things, that it's easily understood by humans and by machines. It's both. And I think I had an interaction. I just want to share this quick little anecdote. I had an interaction, this was several years ago, with another vendor that was selling an analytics tool to healthcare organizations. And I asked this individual, I said, well, what do you do about standardization, and what do you use for a terminology management tool? How do you do this before you apply all of your algorithms and build this great analytics tool that you have? And he said, and his response was, they didn't do any of that. They didn't clean up the data. They didn't standardize it. They didn't do anything. And I kind of looked a little puzzled, I'm sure. And I quote, he said, analytics on bad data is better than analytics on no data. And right, I had the same look on my face, Evgeny, as you have on yours. I just thought, I don't even know what to say, because that is completely inaccurate, really. I mean, because when we're talking about this, and Evgeny, you and I have talked a lot about this too, we don't only want to look at train our AI models on bad data that thinks that the air diet is the best thing to do for optimal health, right? We want to incorporate good, clean, accurate data. Of course, some of that air diet thing is going to come into play too, but we need to train it on data that's actually understandable and relevant. So I think it's shifting. I haven't had an analytics person say that to me in the last probably 4 years, so that's good, and we're making progress.
Yeah, I'd like to say, what's better than analytics on bad data? Analytics on good data, and there's no excuse anymore because the tech is
Right.
out there. The services are out there to make it happen.
Absolutely.
Well, I mean, that's an interesting statement, but on the other hand, you could argue, what is bad? Because it's bad according to certain person's opinion, right? You always view it in the context of a certain use case. So if it doesn't really help you advance that use case because you missed that information, or that information is incorrectly projected into the use case that you have, then you will treat it as bad. That doesn't necessarily mean that your data is bad for some other use case. So I would be careful with just that classification. I think that what we have done with the semantic product is giving the possibility not to narrow down the choice to just a normalization. I will normalize it to that set and nothing else. I'll actually add layers of understanding, and that's why I like the value sets, and especially the extensive and intensive value sets that allow you to actually classify things and build those classifications without necessarily touching the data. And in a lot of cases, that's actually a better approach than saying, let's ingest everything into a data warehouse and normalize it into the narrow understanding that I have today, because you will lose a lot of the things through that normalization and that ingestion. And if you look at the large language models, they have taken a totally different approach. I mean, they take the entire internet as a training set. And yes, you will get into the chat GPTs with over 500 billion of parameters. That's what it is. It's enormous. But as a matter of fact, that still works. Yes, you need huge machines to deal with that, but that's also a valid approach. Yes, you have the other side, which is the kind of the llama models of Meta, the old Facebook, which takes like a 7 billion or 13 billion parameter and then specializes it by building layers and layers on top of it with low-ranking adaptation, as they call it. So you have both that are going in parallel, is what I'm going to say. And we don't know exactly which one is going to win. At a certain moment, maybe the ChatGPT brute force algorithm will be the one that is giving the best results. But as we see in the last months, what Llama is doing, which is the Facebook smaller language model, and the open sourcing of specialized data sets on top of it is giving nearly comparable results, is another approach that we could also look at.
Such great points. And I think that brings us to this nice evolution of the conversation to talking about the art of possible with the art of practical. And you've mentioned, we started that conversation talking about, overall the underlying data quality. And you've made the point, and I totally agree, Evgeny, that it's different elements of that data are different, whether it's the metadata or how that data is positioned around the broader context of the set of data or the person, that it's the lens at which you're looking at it that determines what from that data is relevant. And, you could make the case there is no such thing as bad data, right? And practically in the Rhapsody semantic solution, we help our customers with that through value sets and subsets and how they can filter data for their specific purposes, right? I don't know if you want to talk a little bit more about that, Tammy, and how you've seen our customers apply that principle.
Yeah, thanks, Shelley. Our idea of subsets or the value sets, as some of you might already know them, is really that compilation of concepts across one or many code systems that are used for a very specific purpose. So we have some of our customers that are using it for sensitive data filtering, for example, like substance use disorder, or maybe HIV, or any kind of other reportable diseases. And they're using our subset feature to create these data sets or value sets in ways that are meaningful to them. This may include genomics, for example, for some of them, or not include genomics or genetic testing, I'm sorry. But there's a lot of different use cases for that, and how we build those is really important too, because this is a very iterative process. Codes don't stay static for very long. They're growing, they're adapting, they're changing. Some are being retired, some are being added all the time. So that means your value sets need to be as easily updated as those concepts are. So we have some really great features within our solution itself that allow our customers to do that in a really meaningful, quick, and easy way, to be able to update those value sets by meeting a series of criteria that they define themselves, or we can help you define those as well. So it's really an interesting solution to this problem, because again, it's not just a static set. This is something that's evolving and growing over time, just like healthcare is, just like AI is, just like patients are. So we want to make sure that we can tie in and really lean into that evolution.
If I could add, Tammy, the value sets are indeed so powerful because they combine concepts from various code systems. So they're not restricted to a single code system. So in a way, they are doing what mapping does, but a little bit in a different way. And
Absolutely.
I would argue, and that's something I wanted to inject in the beginning, is that we should have probably even talked about standards in FHIR and all that, because that was very notable at HIMSS. But in FHIR, there is an IG, implementation guide, on clinical reasoning. And they talk about knowledge artifacts. And knowledge artifacts are much more than just the data that you store. Those are the value sets, those are the quality measures, those are the care plan definitions, those are the things that you can share between organizations. And I think that's a very interesting path towards, let's call it, democratizing medical knowledge, and formalizing or making medical knowledge computable. If some of you remember the learning health systems that were advocated a few years back, that's, I think, a very good step going into that direction. And I'm happy to see, and there were some discussions on that there are certain groups in FHIR, especially in the standard, that are developing some of those implementation guidelines. Some of them will take a long time to materialize, but for instance, the clinical artifact repository, to me, is a thing that our Rhapsody semantic can play a role in actually a substantial role in it. And as I said, the value sets are just one component of it. There are many others that can be added to it.
Absolutely, I agree with you, Evgeny.
And we've talked a bit too about how we're using AI in Rhapsody Semantic. So we have companies using it to enable their own AI, but we're also leveraging, a rung on this tier of what's possible with AI to make more intelligent the mappings that run through the system. So as I understand it, Tammy, we have, automated mappings as well as manual mappings that can be made. And when setting up those mapping algorithms, we can set them up in a way so that they can learn and get smarter and automate some of these codes that come in and ensuring they're getting to the right code without as much intervention.
Yeah, absolutely. And when we talked about the number of companies or organizations that were discussing or had in their suite of products AI or machine learning, there's, again, we wouldn't necessarily be up on the rank of the list there about AI, but boy, we have it in our product. And like Shelley said, these are tools in the background that are helping drive some of these results in this mapping for you. So taking a lot of that heavy lift away from the folks that are trying to do this really important work and make sure that we're mapping it to the correct target concept. But utilizing the AI and ML and some of the NLP as well to be able to find those elements within your data, within your source data, within the target data that align. And so again, being able to give you those tools to reduce that lift on our customer side, anybody in the healthcare organization that is tasked with doing that, which could be a lot of people, a lot of business units that are really looking to do that, and giving you something that is easily maintainable too, because that maintenance part of it, it's not just, again, it's not a static list. This is very iterative, and how do we support that? And of course, our AI and machine learning, the NLP that we have in our solution helps support that and drive that further.
So Tammy, I would argue that what actually we do in semantics is extremely close to AI, and I will oversimplify it with an example. But for instance, the large language models and those 7 or 13 or 500 billion parameters are nothing else but relations between the different words that exist.
Absolutely.
And we do the same in semantics. It's not just the value of the heart rhythm that's important, because when you say 60 beats per minute, is that high or it's low? Well, it's high if you're sleeping, it's low if you are exercising. So it's all matters in the context and how you connect it to the rest. So that's what actually semantics does as well. It has all of those deep connections and qualifiers and modifiers that actually allow you to really treat the semantics as giving you the meaning of what exactly is encoded in that particular conversation or message or whatever artifact you're dealing with.
Absolutely. And really taking all of those elements and components, don't leave them out there. Like you said before, though, bringing that thing up to the top, elevating the things that are meaningful and reducing the noise, bubbling up the things that are meaningful. And that's what we do with the tools.
Yeah, actually, that's a big topic, and it's a favorite of mine because data is exploding. I mean, data is growing exponentially, but the information that we extract from it is only growing linearly. So if you take it in combination, it means that the signal to noise ratio is practically degrading exponentially. So if you don't have the tools to signal what is really relevant to you, we will be lost in data, and we will not be able to deal with it at a certain moment of time.
And that's where the subsets and the value sets, to your point earlier, and what we've been talking about,
Exactly.
Those are the things that help reduce that noise and elevate that signal. Tell me anything that's related to breast cancer or to diabetes. The other stuff is still important, I get it, but tell me the things that I'm really focused on here, and how does it relate to the other things in the other data that we have? How does it relate? How can we look at those relationships?
And knowing those relationships are definitely not one-to-one when you're looking across these systems and their hierarchies.
You're absolutely
on the phone with a customer recently, one thing they said they liked about the Rhapsody Semantic product was it gave their experts the freedom to be experts. So their data scientists and their clinical terminologists could level their depth in a particular, therapeutic area that they were investigating or in a particular terminology set, and apply that knowledge with the flexibility that the tool has. Letting, there's standard content, right? There are some automated mappings, but there's the flexibility to augment that data to fit and augment those mappings to fit their specialized purpose.
Right.
And I like that quote that you say, Evgeny, it's upping that signal or augmenting the data for the sake of learning.
Yep.
But there's also the other part, which is filtering the data for the context of what you want to use it for the moment. And we've heard that use case of I'm a radiologist, I'm looking at the study, and I need only the part of the medical record that's related to that particular study. And I don't want to have access to an EHR with all the different things that have been done for a chronic patient for 20 years. So how do you get that summary? That's why actually these generative AIs have a very interesting application in healthcare by creating those summaries, which are very specific, very context sensitive to the problem that is being analyzed, whether it's a diagnostic problem or it's a therapeutic problem. But those are the things that semantics actually help, because you provide these layers of filtering in order to be able to get to the things that are relevant in that particular context.
Great conversation, and say between the hours we spent prepping for this and this conversation, we haven't run out of things to talk about yet. One thing we haven't touched on though is, it's at the core of what Rhapsody does, right? It comes back to integration and getting access to that data from customers, from open source data sets, from your data lake, whether that's internally within an organization or externally. Making sure you have a means to bring that data in the format that you need it. And one of the themes, Evgeny, that you said stood top of mind for you after HIMSS was overall use of APIs to accelerate the initiatives that provider organizations are working on. Is there anything you'd like to add on that point?
Yeah, absolutely. I mean, APIs are predominant, and that's why I mentioned standards. But I also mentioned the way that healthcare is so dynamically organized today, with a lot of mergers and acquisitions and connections to outside ambulatory services, to downstream service providers. It's an ecosystem. And practically, just like in a hospital, a clinician needs a multitude of applications to be able to do their job. Imagine in an ecosystem, the need to be able to connect those different applications. So it's not just the data, it's those applications to be relevant. They need an ecosystem to function. They need a mechanism to collaborate with each other. And some will be very internal, some will be external. Like, for example, that's why we are developing the API gateway in Rhapsody, because some of the things might be actually externally focused. And we talked with Tammy about even terminology, even the semantics. You might expose some value sets externally of the organization through a standard FHIR terminology services, while you maintain a majority of mappings and other value sets internally. It's the same for the APIs. Some can be used internally, some can be used externally, for example, to offer patient access to their vaccination records. So yeah, it's such a variety of uses of APIs, so that it deserves a layer that manages this in a central point for security reasons, for monitoring, for auditing and logging, and an abstraction of different authorization and credentials profiles, but also at the same time to be able to provide for that dynamic use, because nothing is static. It changes every day.
Absolutely. And I think I'd be remiss not to talk about, Tammy, all the APIs that come out of the box with Rhapsody Semantic to facilitate easy connectivity to those external data sources or internal development pipelines.
Yeah, we do. Out of the box, I think we're at right around 100 different APIs, and just ways to get your data in the ways that are meaningful to you as an organization. Everyone's got a different use case about what they want when they're looking at the data. How do they want this transformed, essentially, or how do they want this displayed? And there's so many different ways to do that. So I think that we'll come to where you are, right? So we come to where our customers are. We meet their customers' needs just based on the vast amount and the vast variation of those APIs and what we can deliver with those. And I think the other really important thing, you know, we talked a lot here, Shelley, about what AI does and how it's going to transform healthcare. Another part of it, though, is coming back to that foundational layer when we talk about this, and having the semantic terminology really be your foundational tool when you're talking about building any AI or any tools on top of it. Got to have that solid clinical data foundation to be able to do any of the work that you're doing. And that's really where we're standing in our semantic interoperability place in terms of the entire suite. When we're looking at how we tie this all together, understanding that we have to connect, we have to cleanse, we have to classify this data. And so you can build on top of it. This is not done all by itself. This is not just one-stop shopping, right? It is for our interoperability suite, but there's so many components that we have to add on together, just like you mentioned in one of your previous slides. But bringing it all together, making sure that it's standardized in something that's meaningful and relevant and understandable by humans and machines, I think it will take organizations in the healthcare ecosystem and industry, that community. That's where we really need to start and make sure everybody's got that same foundational layer to be able to build and grow, and not only for revenue improvement, like Evgeny said, but also how it impacts a patient. I think that's really important too. We've got to bring it back to the patient too, how this standardization can really help the patient.
Exactly, because that patient is a patient. That patient's not in their perspective, a distinct user in this system versus a distinct user in this system, or a member of the payment plan, or a citizen in a public health region and a patient at this clinic, right? That's just one person. And although in the system that might be multiple persons with disparate documentation of their problems and diagnoses, you know, to them it's one problem, it's one diagnosis. So we have to figure out how to reconcile that to follow that person accurately.
Absolutely.
Yeah.
And maybe to measure that, because if you think about giving access to, which happens by the way in many jurisdictions, giving direct access to the patient to their record, and you have to give them also the explanation of what they see, and what the clinician sees and what the specialist sees is also two different things, as a matter of fact. And the patient will need these explanations. So the semantics is also a tool for education, because it has a lot of those synonyms, a lot of those additional things that can actually be used to create provider-friendly, patient-friendly explanations of the same patient record that exists in one place. And it's not a single solution that will deliver that. It will be a multitude of different solutions that are directed at different profiles. A genomics person will need completely different information, just like a pathologist will need completely different information. And the patient themselves, if they want to be engaged, and they will be engaged, finally, we want them, they will need different interfaces and different applications.
I agree.
Yeah. Well, this has been a great conversation. Thank you, Tammy. Thank you, Evgeny, for joining me on the webinar, and thank you for those of you who tuned in. So if you have any questions, don't hesitate to throw them in the chat or reach out to us via the website or otherwise.